So if you have a string, can we regard this as a string? Will you hold this? No?
No.
Why not?
Because for a string, you usually regard as thickness negligible.
And this thickness is not negligible.
Or depends on the situation.
Depends on the situation. What situation are you talking about?
This is like 100 kilometers and only.
Oh, that's brilliant expression. Yes, yes. Yes, depending on situation, depending on wavelengths you have interest. If you have interest in this kind of vibration, very long, or if you have interest in this kind of vibration, this is shorter than this one, okay? The thickness, contribution of the thickness becomes severe and severe if you have very short wave over here. Okay, for short wave, this has to be regarded as a beam. For very long wave, this can be regarded as string. And the other very intuitive expression that can distinguish the beam and string is the following. If I push this using point force, then the string, the shape of deflection of this spring would be like this, right? Therefore, the string allows what? Discontinuity in a slope. Because it is string. What does it mean by string? String, as he pointed out, can only transmit a tension. Right? And the beam, for example, tension, the beam can transmit tension as well as what? Momentum, bending stiffness. Yeah. Your answer was quite very close to the true answer. Bending rigidity, EI. What is the role of EI? If I push it, then this cross section try to be bended, but try to oppose the moment that is acting on this element. Therefore, it sustains the curvature. The curvature has to be finite. In other words, the slope change is allowed. So this kind of slope change is not possible for the beam, but the slope change rather look like this. Smooth. Okay? I always ask this kind of question when you enter the PhD course. In PhD course, we have oral examination, and I say, what is your interest? If somebody say, I'd like to do the research in solid mechanics, then I ask you, what is the difference between string and a beam? And very interestingly, there are very few students who really answered the gave us the true answer. Now you understand what is the difference. Okay. Okay, therefore, let's start with the string, beam, plate, shell, membrane. Right? Okay? So, let's start with the simplest case to understand the distributed parameter system. Let's start with the string. Okay? Okay. Suppose we have a string like this. And we would like to know how this string vibrates due to some excitation force. And say this is F, X, and T, meaning that we are using coordinates that measure the displacement, and this is X, and I'd like to measure the displacement of string Y, and that has to be depending on X and time. Okay, now the displacement is not just a function of time, but also a function of X, meaning that the displacement of a string depends on the position as well as the time. Then, what is the next step to understand the vibration of the string? Okay, then, again, let's see what we did for a single degree of freedom system case. We model this, and we set up the coordinate X, that is a function of time only. And we suppose there is a force. Try to understand the behavior of this single degree of freedom system, what we did. Free body diagram, because the motion of the system is governed by the Newton's second law. Same thing. We need to draw free body diagram, or we have to apply governing law, that obviously second law, Newton's.